Hello everyone, this is Rama Devi. So today I'm here to give you the key and solution for the KCET examination that has taken place today. So you all know that KCET exam 2023 physics has taken place today, and I'm going to provide you the answer key and solution. And before proceeding, let me give my introduction. I'm Rama Devi, physics faculty, having 12 plus years of experience in coaching students for the examinations like JEE mains and NEET examinations. So today we'll see the paper analysis and also how it has taken place and how are the questions, everything we are going to analyze. Excuse me for that. The physics question paper analysis. How easy or difficult was the paper? According to the students, for the students, if we think, the paper was a bit difficult. Okay, so the paper was a bit difficult. So the students who are preparing for the examination, so it was under the category of difficulty level. Those who prepared for the JEE mains exam, they found the paper moderate to difficult. So this was the analysis. This is the basic analysis. Next, how many questions were easy and how many are difficult if we go through that analysis? Nearly 23 questions were under easy category, 27 questions were moderate and 10 questions are difficult. So this can be considered as moderate to difficulty level is less, easy to moderate question paper. So how much an average student expects? An average student can expect between 20 to 25 marks. And where are they? Any out of syllabus questions? No. Beyond NCERT questions, 2 questions were asked actually beyond NCERT. So one on cyclotron and the other on damped oscillator. So yes, I found this damped oscillator question a bit out of syllabus. So that is the analysis. Now how was the paper in comparison to last year? Comparison to last year, the paper is difficult. Yes. The questions were lengthy and more in calculation. Yes. Were there any mistakes in the question paper? No. Do you think there is a change in pattern when checked? No. There is no change in the question paper. So these are the frequently asked questions. You will be provided with this PPT anyway. So you can go through all this. So let's start with the question paper analysis. So first question is, the block of mass m is connected to a light spring of force constant k. So spring constant k is given. The system is placed inside a damping medium of damping constant b. So this is the question. I found that it is a bit out of syllabus. So this question actually, it is not calculation based. It is a memory based question and the direct option is D. The correct option is D. X is equal to A e power minus B by M cos omega t plus phi. So this is the question, direct answer. So this is a direct memory based question. But yes, you people might not have gone through it. Moving on to next question. The speed of sound in an ideal gas at a given temperature T is V. Okay, speed of sound is given and the RMS speed of the gas molecules is given at the temperature VRMS. Now the question is the ratio of the velocities of V and VRMS for the gases helium and oxygen gases are. First of all, you should know the helium and oxygen. Why they are given is you should identify the molecular weight. So first thing is you need to know the formula for speed of sound and RMS speed. What is the formula for speed of sound? Let us write Vs. Okay, V. Okay, V is the speed of sound. So V equals to root over gamma RT by capital M. Okay, this is the formula for speed of sound. RMS speed, you already know the formula, root over 3RT by capital M. So here the question, in the question it is given the temperature is constant. So when the temperature is constant, the speed depends inversely proportional to root over capital M. So now we just need to find out the ratio. Okay, so you just need to know the ratio of velocities of V and VRMS. So if I take V by VRMS, I am only left with root over gamma by 3. RT by M gets cancelled. So when RT by X gets cancelled, now we are left with gamma. So that gamma is applied to helium and oxygen. Helium is a monoatomic gas and oxygen is a diatomic gas. So for a helium monoatomic gas, gamma value is 5 by 3, and for a diatomic gas the gamma value is 7 by 5. So you just have to substitute the gamma values over here and you will get the answer. So the correct option would be option A. Hope you are clear with it. Now moving on to next. A positively charged glass rod is brought near uncharged metal sphere which is mounted on an insulated stand. So there is a glass sphere. This is uncharged. Uncharged meaning how many ever number of positive charges are there, those many number of negative charges are present on it. Now you are bringing a positively charged glass rod near to it. So you are bringing a positively charged glass rod. So what happens is when you bring a positively charged glass rod, just what happens is the charges just get rearranged. So all the negative charges are pulled towards the glass rod and all the positive charges are repelled. But still the charges are not gone anywhere. They are still on the sphere only. Now if the glass rod is removed, okay, glass rod is removed. When glass rod is removed, again the charges get rearranged. So there is nothing happening here. The amount of charge is remaining the same. So total charge, how many ever positives are there, those many negatives are there. So the total charge is 0. So option A would be correct. Most of this is a very simple question, but yes, it is a tricky question I feel, because it makes the students to get confused. So I like this question. Next, in the situation shown below, okay, this is a situation. You can see that there is a negative charge and there is a positive charge. That means this is a dipole based question. And you can see that the P point is along the equatorial line. So dipole and point P. Here you need to see that the point P is on equatorial line. So immediately the formula has to strike to your mind anyway. The conditions given, see, small q is much smaller than capital Q. Okay, and then R is much greater than A. When R is much greater than A can be neglected. So the net force on free charge minus Q and net torque. We are asked two questions here, net force and net torque. So for force we use the formula F is equal to EQ. Okay, so what is the formula for E? For E, when R is much greater than A, the formula is 1 by 4 pi epsilon naught P by R cube. P by R cube, and Q is also there, so we write the Q. Okay, F is equal to 1 by 4 pi epsilon naught. This is the formula. Okay, but now we need to know the direction also. For direction, if you just draw the lines, like if you can analyze, A is negative, at A negative charge is there, at P negative charge is there. The minus Q repels this small minus Q. So in which direction? This is the direction in which it repels. Next, this is a plus Q, this is minus Q. So this plus Q attracts minus Q. So this is the direction. Now, if I take the resultant of these two forces, then the resultant lies along this direction. So this is positive x direction, which is nothing but I cap. So the correct answer is I cap question part is correct. So answer is 1 by 4 pi epsilon naught PQ by R cube I cap. This is the force. Now when we get the force, we can calculate the torque also. What is the formula for torque? Torque is equal to force into perpendicular distance. Okay, torque is equal to force into perpendicular distance. So tau is equal to R bar cross F bar. Let us take tau bar is equal to R bar cross F bar. What is the direction of R bar? R bar is along J cap, right? So R bar is along positive y axis. You can see that this is the positive y axis J cap. Okay, this is J cap. R bar is along J cap. So R J cap cross F is along I cap. So J cap cross I cap. So J cap cross I cap, you will get minus K cap. Okay, minus K cap, and you need to multiply with R here. So one R is removed. So answer is 1 by 4 pi epsilon naught PQ by R square minus K cap. So with this, the answer would be, let me shift the slides. With this, the correct answer would be D, minus K cap plus I cap. So this is the correct answer. Next, moving on to next question. Pressure of ideal gas at constant volume is proportional to. So the formula is P is equal to 2 by 3E. right? Pressure and E relation. So it does not depend on the volume. So the correct option is option B will be the correct answer. The average kinetic energy of the molecules, because volume is constant. So we can take this formula. So P is equal to 2 by 3 E. The correct option is B. Next, the electric field, question number 6. The electric field at a distance R from infinitely long uniformly charged straight current carrying wire. Okay, for that, the formula lambda, whose electric linear charge density is also given lambda E1. So for a straight current carrying conductor infinitely long at a distance r E1, due to this current carrying conductor, the electric field formula E1 is equal to lambda by 2 pi epsilon naught r. Okay, distance r. Distance is r. This is the formula. This is a direct formula we get from the Gauss law applications, one of the Gauss law applications. Now, the same conductor has same linear charge density is bent into semicircle. It is bent into semicircle. For semicircle, actually the formula is E2 is equal to lambda by 2 pi epsilon naught r sine theta by 2. For a semicircle, what is the value of theta? Here theta value is 180 degrees because semicircle makes angle 180 degrees at its center. So the answer is sine 180 by 2 sine 90 degrees. So the answer is E1 is equal to E2. So the correct answer is option C. Okay. Next. Question number 7. 5 capacitors each of value. So here capacitors are given. Simple question is the equivalent capacitance between A and B. You need to analyze between A and B. See here I'll give you a trick if you can observe carefully. I'll go by potential method. So if this point is at potential A, then when the charge or current passes through capacitor, there will be a potential drop. So let me consider that this point is some other potential C. Now when I go in this path, there is no more capacitors, no more devices. So even this junction is at same potential. If I go this way, there is a capacitor, so potential changes. But if I go this way, there is no device at all. So I can write this also as C. Now going from the other side, you come this way or this way, there is a capacitor on its path. So whenever there is a device, there will be a potential drop. So I will consider this point, this junction at some point D. Because there is no device at all here, this also is at D and there is no device also. So this junction is also at D. Now just mark the points A and we need between A and B. So just write down like this. And somewhere here put C and somewhere here put D. Now if I take this capacitor, this is between A and C. So draw A and C, this is done. Now if I take this capacitor, it between A and D. So let me write A and D. If I take this is between C and D. So this is C and D. Next, if I take this is between B and C. So this is B and C. And last one is between B and D. Let me write B and D. Okay, so all are 1 microfarad. So this is a balanced Wheatstone bridge condition. It is a balanced Wheatstone bridge condition. It is a balanced Wheatstone bridge condition. So there is no current or charge flowing through this. So now these two are in series. These two are in series. So here comes 1 by 2 microfarad and here comes 1 by 2 microfarad. Now these 1 by 2 and 1 by 2 are in parallel condition. So the answer comes out to be 1 microfarad. Option A is correct. Next, question number 8. Uniform electric field vector E bar exists along horizontal direction. Okay, E bar is in this direction. You can see here. Electric potential at point A is VA. Here the potential is VA. Now a small point charge Q is slowly taken from A to B along the curved path. So this is the path in which it is taken and the potential at B, now let us take it as VB. Okay, the potential energy we need to find out. So potential energy formula is U is equal to Q into V. Q charge into the potential. So but yes, here we need to check that whenever it is taken like this, the potential energy at B is actually the potential difference. If you take, it is V which is at higher potential. B is at higher potential and A is at lower potential, and charge is taken from A to B, right? So here the work done in taking from A to B can be written as work done is equal to Q. Work done is always stored in the form of potential energy. So whether you calculate potential energy or work done, Q into VA then plus Q into EX. What is this EX? EX is nothing but potential difference. You know, E is equal to V dV by dr. From here, V is equal to E into dr. From that we got this. So here the answer comes out to be EX plus VA into Q. VA is potential and this distance is nothing but X. You can see in the diagram. So according to that, the correct answer will be A. Next. A parallel plate capacitor of capacitance C1 with the dielectric slab. Okay, C1 is calculated when dielectric slab is in between the plates. So whenever dielectric, remember that whenever dielectric slab is between the plates, the capacitance of the capacitor increases. Now it has a potential difference V1. When the dielectric material is there, its potential is V1. Now when the dielectric slab is removed, keeping the capacitor connected to the battery, that means V remains the same, potential remains the same. Okay, so here we need to understand that keeping the capacitor connected to battery, same battery, that means V1 will be equal to V2. Same battery, V1 will be equal to V2, and we also know that C1 is greater than C2 because as I told you, whenever we introduce the dielectric medium in between the plates, the capacitance of the capacitor increases. So when dielectric is removed, capacitance decreases. So C1 greater than C2. So what would be the correct answer? Option B will be the correct answer. Moving on to question number 10. A cubical Gaussian surface has a side of length A. The diagram has been shifted to next part. So here just remember that A, B, C, D, E, F, G, H has 6 kilonewton per coulomb, 9 kilonewton per coulomb. This kilo need to be given value. Many of the students get confused here this kind of questions. They just out of tension or stress, they just forget to see about this kilo and there it goes wrong. So I'm shifting to the diagram part. So here this is 6 kilonewton per coulomb and here it is 9 kilonewton per coulomb. That means E1, E2. Let us take this is E1, this is E2 value let us take. We need to calculate the flux. Now if you see, observe carefully, for this part of for this ABCD area, the area vector is directed this direction, and for GFEH, the area vector is directed in this direction. Here electric field and area vector along same direction. Here electric field and area vector in opposite direction. So here theta value will be 180 degrees and here theta value will be 0 degrees, and the formula we are going to use is phi is equal to E ds cos theta. E dot ds, you can remember, E ds cos theta. So ds is nothing but area vector. So finally when ds is nothing but the area vector. So here we can calculate the charge. We need to calculate the charge. So we will equate this to be Q by epsilon naught. Okay, so we have to take the resultant over here because two electric fields are there in opposite directions, this way and this way. So finally only phi, this part I will solve first. Okay, for this part if I solve, the answer is phi is equal to the electric field, both are in opposite direction, so one is positive, other one is negative. Here this is 9000 Newton per coulomb and this is 6000 Newton per coulomb. Am I right? So after applying kilo value. So finally when I calculate area, how do you calculate area? Area you will calculate as side into side. Side is given as 10 centimeter. So 10 square into 10 power minus 4 meter square. You need to convert it into SI units. So when I substitute all those things here, I get the flux value as 3 into 10, that is 30. Okay, now I have to equate this 30 with Q by epsilon naught. So 30 is equal to Q by epsilon naught value is given as 9 into 10 power minus 12. Okay, so from this we get Q value as actually 27 into 10 power minus 11, 27 into 10 power minus 11, but answer we need to get in nanocoulomb. So when you convert, you will get the answer as 0.27 nanocoulomb. 0.27 nanocoulomb, answer B is correct. Okay, next. 4 bands of color coded resistor are 4 colors. One is gray, red, gold and gold. Okay, gray, red, gold and gold. So what is the value of resistance? What is the value of resistance? How do we calculate? You just have to remember the BB Roy of Great Britain color coding. If you remember, gray comes out to be the number 8 and red comes out to be number BB Roy. So number 2. Red comes out to be number 2 into then what is gold, and gold is given. So one gold, actually gold we have 5%, right? Do you remember? For gold actually we have the 5%. Okay. So 5%, if you convert 5 by 100, then you will get 1 by 20. So this becomes yes, okay. So this becomes 10 power minus 1. So 10 power minus 1 plus or minus 5%. So the correct answer is 10 power minus 1 is 8.2. So I have to go with the option C. Next. Question number 12. A wire of resistance R is connected across a cell of EMF E and internal resistance R. Okay, the current through it is I. In time t, the work done by the battery. So here this is a very conceptual question, direct question. So I square RT, option B is correct. This is the easiest question I found. Next. For a given electric current, the drift velocity of conduction in electrons copper wire is Vd and mobility is mu. You should know the relation between mobility and drift velocity as mu is equal to Vd by E. Okay, mu is equal to Vd by E and I is equal to NEAVD. Okay, these are the relations that work out here. So by applying those relations, actually we get the option D. Vd increases, mu remains the same as mu is equal to Vd by E. Mu will not depend on current, it depends on electric field. Okay, so that is the answer. Now moving on to question number 14. The 10 identical cells, how many? Number n is equal to 10 identical cells, each of EMF E is equal to 2 volts. Internal resistance is represented with small r, are connected in series. This is important for us. With 2 cells wrongly connected. Okay. So always remember that whenever cells are connected wrongly, then the number of cells remaining, that means working, comes out to be n minus 2m. So how many are damaged? 2 times you should remember. So 10 minus 2 gone down, so 2 into 2. So 2 into 2 is 4. So total 6 cells only working for us. So this is the main concept. What is the current through the resistor? So current through the resistor formula is I is equal to N into E by capital R plus NR in NR. But here in place of N, I have to take N dash because damaged cells are there. So what is N dash? 6 into E is 2 by capital R is 10. Plus resistors reversely connected or directly connected, resistance don't make any difference. So here comes 10 only, 10 into 1 ohm. So by solving this, you will be getting the answer. What is the answer you will be getting is, okay, by solving, let us solve this. 6 2s are 12 by 20. So you have to cancel out. Okay, so when we cancel out, okay, sorry for the distraction. So 4 3 times, 4 5 times, so 3 by 5, answer 0.6. Yes. Now moving on to, yes, whenever you just see this, you find out that this is an infinite resistance case, infinite chain based. So when infinite chain based diagram comes, so what we need to do? We need to identify the repeated cells. So this is the repeated cell. So keep one cell aside and the rest of the cells, give them the value as X. So here I am going to draw the equivalent circuit again. So this is the repeated cell I identified. So all are 2 ohms, A point and B point, all are 2 ohms. Next, the rest of the point, whatever rest of the portion is there, the equivalent resistance of that rest of the portion, I am considering it to be X. Okay, so this is X. Now see, these 2 and X are in parallel. That answer is in series with 2 and 2. So how do you write the equation? So 2 into X, 2X by 2 plus X is in series with 2 plus 2. And what will be the equivalent? See, from infinity, you remove one cell and again add cell. Add that one cell. From infinity, remove one, it is infinity. To that infinity, again add 1, it is infinity. So the answer also comes out to be X. Just solve this equation, that's it. Now from here, it's only pure mathematics. So 2x plus this is 4. 4 2s are 8 plus 8x is equal to, no, 8, what am I doing? 4 2s are 8 plus 4x. 4x is equal to, again multiply, so 2x plus x square, 2x get cancelled. So what is the equation remained? X square minus 4x minus 8 is equal to 0. Find roots and find the value of x. How do you find? Minus b plus or minus root over b square minus 4ac by 2a. By using this formula, you can find the value of x. And that comes out to be option A. You can calculate and see the option comes out to be A. Next, a charged particle is subjected to acceleration in cyclotron as shown. Okay, cyclotron, this is a completely theory based question. So this is a completely theory based question. So the charged particle undergoes increase in its speed. Usually increase in its speed happens only electric field is responsible to make it more accelerated. So the correct option would be D. Only in the gap between D1 and D2, because inside the D's electric field will not be present. It will be absent. Inside the D's only magnetic field, outside the D's electric field. So the correct option is D, and this is a complete concept based question. Okay, this is only a conceptual question. Now moving on to next. The resistance of carbon resistor is given. Color code of the third band is. Which is third band? This is first band. This is second band. Third band is always taken as 10 power. Now what is 10 power is this? This is 10 power 3. So third band is 3. So color number 3 comes. BB Roy of great. Okay, BB Roy is 0, 1, 2 of great. So G will be coming. No, BBRO, orange. Sorry, my calculation gone wrong. So orange is the correct answer. So B will be the correct option. Now moving on to question number 18. A moving coil galvanometer is converted into an ammeter of range 0 to 5 milliamperes. Okay. Now the galvanometer resistance is, let us take it as capital G, and the shunt resistance is S. Okay, there are 50 divisions in the galvanometer turned ammeter on the either side of the 0. Its current sensitivity is. Okay, so for current sensitivity, the formula is, here 100. When we calculate 100 by 5 into 5 milli, so 5 into 10 power minus 3. Why did I take 100? Because here 50 divisions on either side of the 0. So this side 50, this side 50, total 100. So 2 into 10 power 4. So the correct option would be, no, sorry, my bad. Ampere, both the options are given correct. What is this? Typing mistake, I guess. C and D. No, sorry. Yes. See the units, I got confused. So no, option D is correct. So divisions per ampere is the correct answer. So this is how usually, yes, how I got confused. It makes the students also get confused. So a very tricky options are given, I would say. So question number 19, positively charged particle. Here y is equal to 2mv by qb is given. Okay, so in time t, what is the angular momentum of the charged particle? Let us see the diagram so that you can understand clearly. Here what happens is it goes, and what is impact parameter, meaning it has to come like this. Okay. So for that, now we need to find out angular momentum. Angular momentum is L bar is equal to R bar cross P bar, right? L bar is equal to R bar cross P bar. And here R bar and P bar are perpendicular to each other. So we can take directly 2mv by qb into mv, momentum. So this is the formula. Now q bar cross b bar is equal to mv by r, that we already know. Okay, q into b, not q bar, sorry, charge is a scalar quantity, mv by r. R is equal to mv by qb. From that, in place of qb, if I substitute mv by r, so we get what is the answer? MVR we are getting, no? L is equal to MVR. Okay, so T is equal to 2 pi R by V, because time is equal to total distance traveled by velocity. So 2 pi mv by qb. 2 pi mv by qb you get. So the answer is 2 pi m by qb. So these all things if you substitute. Here there is a small problem. I think the options are not matching. So there is a ambiguity in this question. So anyway, you will be given detailed. This is what I am getting. So this is the question. So there is a little ambiguity. The options are not matching for this. Okay, let us go to question number 20. Question number 20, Curie temperature and temperatures are given. Okay, susceptibility we need to find out. First of all, this is only a formula based question. You should remember the formula for susceptibility and temperature relation. The formula is susceptibility is equal to C by capital T minus theta C, Curie temperature. So very simple formula. You just have to see for cobalt and iron. So if I write for cobalt temperature is at 1400 Kelvin and it is at 1600 Kelvin. So C by 1600 minus 1400 you will get 200. Similarly, for iron if you write C by 1000 minus 1600, it is 600. So just take the ratio, you will get the option A. Answer A you will be getting. Next, moving on to question number 21. The torque acting on a magnetic dipole placed in uniform magnetic field is 0. Torque formula you should remember, tau is equal to mb sine theta should be equal to 0. When it becomes 0, when sine theta becomes 0, that means theta is equal to 0. So the option is D, because the angle between those two becomes 0. Next, question number 22. The horizontal component of Earth's magnetic field at a place is, let us name this as BH, horizontal component. Dip at that place, theta is equal to 45 degrees. The resultant magnetic field. Resultant magnetic field is actually B. B is question mark. Direct formula based question. This is an easy type question. BH is equal to B cos theta, right? So from here, B is equal to BH by cos theta. So BH value is 3 into 10 power minus 5 by cos 45. Cos 45 is 1 by root 2. So the answer is 3 root 2, right? So the correct option will be option B. Question number 23, proton and alpha particle. So first thing, whenever proton and alpha particle you see, just remember about their charges and masses relation. If I consider the charge on proton as Q and the mass of proton as M, then for alpha particle the charge becomes 2Q and mass becomes 4M. First thing, this has to come into your mind. Now question is, they are moving with the same velocity, okay? Enter uniform magnetic field. So here B also same magnetic field, same velocity. With their velocities perpendicular. Why this is given is, whenever velocities are perpendicular, the particle takes a circular path. So what is the ratio of radii? What is the formula I have to use here? R is equal to 2 pi m by qb, right? R is equal to mv by, what is the formula for radius? R is equal to mv square. First of all, if I just derive mv square by r is equal to qvb, b gets cancelled. So R is equal to mv by qb. Okay, this is the answer. So R is equal to mv by qb. V same, B same. So R of P by R of alpha is equal to mass of P by mass of alpha into charge of alpha by charge of proton. So just substitute mass of proton. I have considered 4m by m into 2q by q. I have taken the reverse part. Yes. m by 4m is equal to. So the correct option will be option B, 1:2. Next, question number 24. A metallic rod of length 1 meter held along east-west direction. So if I consider this as a, if always directions you remember, this is east, this is west. So there is a metallic rod. It is its length is along east-west direction. So L bar is equal to L into I cap. Next, allowed to fall down freely. Okay, it is falling down. Given horizontal component of Earth's magnetic field is given, EMF induced. This is motional EMF. Okay, this is an example of motional EMF. So EMF induced formula will be E is equal to BLV. Okay, only BLV. But in place of V, what can I write? BL. V is directly not given, but time is given. So I can take time as B as B is equal to U plus AT, but it is falling freely downwards. So U is equal to 0 and A is equal to G. So the final formula is BL into G into T. So just substitute the values and you will get the answer as D. Okay, because just multiply 3 2s are, L is anyway 1 meter. So this is the answer. Now moving on to next one. A square loop of side 2 meters enters a magnetic field with constant speed as shown in the figure. Okay. First of all, you should remember that first thing is it is outside the loop, this side, and finally it is coming out of the loop. So finally the current direction would obviously be reversed. Okay. So that is the main thing you have to remember. So the correct option, I think we can see the options here. So the correct option would be option B because the current is reversed in direction. So the correct option would be option B. Okay. Moving on to next question number 16. In LCR circuit at resonance meaning omega L is equal to omega C or okay, yes, this is the condition you can take. The phase difference between the voltage and current is. At resonance, what is the phase difference? The phase difference at resonance, it would be 0 because the diagram if you draw here, this is the current, this is VR and this is the direction of VL and this is the direction of VC, right? VL is equal to VC, so we have only 0. Next, an ideal transformer has an ideal transformer has turns in the ratio of 10, that is NP by NS is equal to 10, that is given when primary is connected to 220 volts. So primary voltage is 220 volts and frequency is given. The power output must be calculated. Okay. So in an ideal transformer, the efficiency is always 100%, right? The efficiency is always 100%. That means the power output is always equal to the power input. The power output is always equal to power input. So it is equal to power input. So this is kind of, again, I felt this is a kind of tricky question because people try to solve the problem, but yes, it is a completely concept based question. Again, this is a conceptual question, no need of any values to be considered. Next, a current in a coil changes from, okay, in this much time, the magnitude of EMF induced in the coil is given value of self-inductance. Which formula you will select? The formula is E is equal to, let us not take only magnitude, L into di by dt. Let us find out what is di by dt. Di by dt is change in current by time. So 5 minus 2 by 0.3. So that is 3 by 0.3. So 3 by 0.3 is 10, right? So 1 is equal to L into 10. So answer is 0.1 millihenry. Yes, because it is reciprocal. So answer would be, no, 10. Oh yes, 10 millihenry. So just calculate and see, you will get the answer as, no, 10, 1 by 10, 0.1. So let me calculate. L is equal to, you will get 0.1 Henry. If you want to convert, yes, convert into 1000 by 1000. So the correct option will be option A. Next, question number 29. The ratio of magnitudes of electric field to the magnetic field. Okay, so ratio of electric field to the magnetic field. This is electromagnetic waves question. So this is always equal to C, whose value is 3 into 10 power 8 meter per second. So it is of the order of 10 power 8 meter per second. Option B, very, very easy question I feel. The simplest question. Next. For a point object, which of the following always produces virtual image in air? Is it plano convex lens? Is it biconvex lens, convex mirror and concave mirror? No, concave mirror is wrong answer. And biconvex lens is a wrong answer. Plano convex, wrong answer. So convex mirror always produces virtual image, right? Okay, this is also again a conceptual question. For a given pair of transparent media, the critical angle for which color is maximum? So color, whenever color comes, it is related to wavelength. Wavelength is again related to the refractive index, because we know that refractive index is reciprocal of the critical angle. So for which the critical angle is maximum. Critical angle is maximum. Refractive index should be minimum. Refractive index is minimum for red color. So the option will be A. Next. An equiconvex lens made of glass of refractive index 3/2 has focal length f in air. So this is the focal length in air and completely immersed in water, and refractive index given, percentage change in the focal length. So percentage change in the focal length we can calculate only when we know the formula. The formula used here is 1 by f is equal to mu minus 1 into 1 by f is equal to mu minus 1 into, you can take as r minus 1. So okay, so I can take it as x, the distance, because the value is not mentioned and it is ratio, so I can take it as ratio. So 1 by f in air and 1 by f in, I just have to calculate 1 by f in air and 1 by f in water and just take the refractive index. So refractive index percentage only we want. So when we calculate f of water, I'm directly writing it here, f of water and f of air is equal to 1 by 8 times of x by 1 by 2 times of x, because I just have to do minus 1, right? So that is the answer. So what is the answer I get when I solve this? I think yes, 400% you will get. Okay, next. A point object is moving constant speed of, this is the object speed. Okay, let us write it as VO. Along the principal axis of convex lens of focal length is given, which is positive because it is convex lens. The speed of image is also, the speed of image, let us take it as Vi, when the object is at centimeter from the, at what centimeter? We need to find out the centimeter. So here the formula is actually, the formula is du by dt. Okay, du by dt is equal to u square by v square into dv by dt. Okay, du by dt is the object velocity, dv by dt is the image velocity. How do I get vu? How do I get v and u? Is 1 by f is equal to 1 by v minus 1 by u. Okay, by using this formula, you can get v by u and then substitute. We need to find out v value. Okay, v we need to find out. So very simple question I feel. So solve it and you will be getting the answer as C. Okay, you will be getting the answer as C. Just solve it by using these two formulae. You will get the answer C. Next. When light propagates through a given homogeneous medium, the velocities of primary wavefronts are lesser than. So if I read, the correct option is C actually. Primary wavefronts are greater than or equal to those of the secondary wavelets. According to Huygens principle, this is a conceptual question. Okay. Moving on to next questions. The impedance, okay, total impedance of the series LCR circuit varies with angular frequency of AC source connected to as shown in the figure. Okay, the Q factor we need to find out. So Q factor, to find out Q factor, the formula here we need to use here. Q factor actually has so many formulae. Here we need to use the formula as omega naught by 2 delta omega. How do I calculate delta omega? So 2 omega naught and delta omega, how do we calculate is, see, delta omega is, one is 600, the other one is 400. So 600 minus 400, 200 radians per second. Okay, so delta omega comes out to be this much. What is omega naught? This is considered to be omega naught, right? So here omega naught value is 500. Just substitute all these values. Very simple question I find. So this the correct option you will get as 2.5. Next. In Young's double slit experiment, the intensity of light, yeah, this is a difficult level question I found. This is a tough question. Double slits is this much given. This is the intensity. The screen slit distance is very large in comparison with slit to slit distance. So the capital D is much greater than small d. The fringe width is beta and x value is also given. Total light intensity at this point. This is the question asked. Okay. So the options are here. So if I use what formula I have to use is I is equal to, because central bright fringe, no, 4I naught cos square theta by 2. Okay, 4I naught cos square theta by 2. So what is theta? How do I find out? So the formula I can use is delta x is equal to y into d by capital D, right? So delta x is equal to 3 beta d by capital D. So by substituting these values, delta x I will be getting as 3 delta. From this again, see, theta or phi, whatever. Phi I have to get. So delta phi is equal to 2 pi by lambda into delta x formula I will be using. And by solving all these things, I will be getting the answer as 8 into 10 power minus 2. Okay. Moving on to next question. A 60 watt source, 60 watt, by seeing the units also you can say that this is nothing but power given. Monochromatic light of wavelength given in nanometers. The number of photons emitted. So the formula, very simple formula. P is equal to N into E by T. T is 1 second. So N is equal to P by E, because T is 1 second. Now E value is not given. So in place of E we write HC by lambda. But HC value directly you can take, if lambda is in nanometers, HC value becomes to be 1240 by 662.5. Directly you can calculate E value here. Substitute P value 60 watts. When you solve, you will get the answer 2 into 10 power 20. Option A will be correct here. Next. So in an experiment, now this is a direct question. Actually, you can remember the direct answer. But if you want the detailed information, the detailed complete solution will be provided below this video in the description as a link. So you can go to that link and you can get. So here slope will be h by e, and the intercept, negative intercept, will be minus h nu naught by e. So the correct option will be D. Actually, this is a direct question. You can remember, because while learning dual nature of matter, we will definitely discuss about this graph. So this is a direct answer I feel. Next. In the Rutherford's alpha scattering experiment, as the impact parameter increases, the scattering of the alpha particle will be decreasing. Impact parameter increases, scattering angle of alpha particle will be decreasing. Next, 3 levels of energy levels of given. See, if you want to remember directly, you can do one thing. You can write, you know that E is equal to minus 13.6 Z square by N square, right? So Z is anyway 1, because this is hydrogen. So Z I am taking 1 by N square. Here N is equal to 1, N is equal to 2, N is equal to 3. If you substitute, this will be minus 13.6. This will be minus 3.4 approximately, and this will be minus 1.8 approximately. So you can easily calculate the lambda values. So here lambda 1, you can just take the differences. So you can take the differences, lambda 1, lambda 2, lambda 3. When you calculate the answer, you will be getting as option B. Okay, this you can remember, or lambda value also you can write down. Next. An unpolarized light of intensity I is passed through 2 polarides kept one after the other. When 2 polarides are kept one after the other, one acts as polaroid, the other one acts as the analyzer, right? So, okay. So, when the intensity of light emerging from second polaroid is given by I by 4. Okay, the formula here, what formula you have to use? I is equal to I naught by 2 cos square theta. Yes, this is the formula we are going to use. In place of I, you have to write I by 4 is equal to I naught by 2 cos square theta, and theta value you have to find out. It comes out to be 45. So 1 by root 2, right? So you can take the square root. So the direct answer, very simple question. Just a formula, if you remember, the question is done. Next. The nucleus with the mass number 220 initially at rest emits an alpha particle. Okay, Q value of the reaction is given. Calculate the value of kinetic energy. So the relation between kinetic energy and Q value is kinetic energy is equal to A minus 4 by A into Q. This is the formula. If you remember this formula, that's it. It is done. And substitute the values, you will get the Q value. Okay, so sorry, kinetic energy value. The Q value is given, kinetic energy. You have to find out the answer you will get as 5.4. Okay. Now moving on to question number 43. A radioactive sample of half-life of 3 years. So what is given here is, why is it not written? Okay, the half-life is given as T half. T half value given, the time required for the activity of sample to reduce to 1/5 of its initial value is about. We need to find out small t. I always say whenever radioactivity problems come, we can use a simple formula as one is n by n naught is equal to 1 by 2 power n. The other one is small t is equal to n into t half. By using these two, you can solve. Here, this is what is n by n naught. N by n naught is n by n naught is directly given as 1 by 5th, right? So 1 by 5th of its initial value is about. Okay. So we have to substitute here, find out small n value and then find out n into t. Okay, that can be one method. Other method is, if you don't remember this, just have to go to the original process. So here, if you are unable to find out n value, we can use another formula, that is directly. We can use n is equal to n naught e power minus lambda t. Find out the value of e power lambda t. How do you get? It is n by n naught is 1 by 5, right? So n by n naught is given. N by n naught is 1 by 5. So n by n naught is equal to e power minus lambda t is equal to 1 by 5. That means e power lambda t is equal to 5. That is how I got 5 here. And then we need to find out lambda t is equal to ln 5. This value we need to substitute. And then when you substitute here, t half is equal to, we can find out. So after solving all these things, actually you should be knowing the value of ln 5. So that is why this becomes a tough question. So option A, you will get the correct answer, because if you know log 5 to the base e, then only you can solve this problem. Next, when a PN junction diode, again some very simple question. So PN junction diode is in forward bias. It is because of the free electron. So this is a very easy question, conceptual question. Next, full wave rectifier with the diodes D1 and D2 is used to rectify 50 Hz. Frequency is given. Okay, so alternate voltage, the diode D1 conducts. We always know that D1 conducts for full wave rectifier is combination of two half wave rectifier we can take. So the correct option will be, it will be functioning for only first one half cycle. So the correct answer will be option 25. Next, truth table for the given circuit. Very, very simple question. The truth table, you just know how to write it. So first of all, A, B and Y. 0, 0, 0, 1, 1, 0, 1, 1. So when we give 0 and 0, 0 comes here and then the 0 comes here. So 0, 0, option 0, bubble is there. So 1 comes out to be, and here comes 0 and 0. Answer 0, 1, 0, actually 0, bubble is there, option 1. So here 1 comes out to be. Next, give 0 and 1. So here comes 0. And here comes 1, 0, 1, actually 1, bubble is there, so it becomes a 0. Next, here 0, sorry, here 1 and 0 comes, 1 and 0, 0. So 1, 0 and 0 on 0, output should be 1. So like this, if you go on doing, you will get the answer. So here correct option would be C. Okay, so you can just try it. Next, the energy gap of LED is 2.4 electron volts. Okay, energy gap is given and switched on The momentum of the emitted photons is. How can I get the momentum? Momentum is P, right? P is asked in the question. So we know the formula E is equal to hc by lambda, right? E is equal to hc by lambda. And when we convert this, h by lambda is P. So E is equal to P into C I can write, right? So from here P is equal to E by C. Simple, very simple. E by C, just do it. You will get the answer. C value is 3 into 10 power 8 meter per second. So substitute, you will get the answer. So the correct option would be option D. You will be getting option D as the correct answer. Next. Moving on to question number 48. In the following, represent is beta negative. Okay, negative beta decay, the number of neutrons. How do we get number of neutrons? Number of neutrons we get by doing A minus Z, right? We get the number of neutrons as A minus Z. So here 210 minus 84, because this is a negative beta decay, this comes to be 84 and this comes to be 210. So number of neutrons 84 minus 210, answer 126, option D is correct. Next, 49. A body is moving along straight line with initial velocity given, okay. Its acceleration A is constant after t second. Whenever we see acceleration constant, remember that we can use equations of motion. After 1 second, so time t is equal to 1 second given, its velocity becomes v. So from here we should know that the initial velocity is v naught and final velocity is v. Time taken is 1 second. A value is a. Okay, we need to find out the average velocity. What is the formula of average velocity? Average velocity formula, total distance traveled or displacement by total time taken. Total time taken, because it is moving in straight line, distance traveled or displacement doesn't matter. So in place of distance traveled, what can I use? S is equal to ut plus half a t square formula we can use, where t is given as 1 second, or else we can use the formula b square minus u square is equal to 2as also. Any answer you do, you will get the answer. B square minus u square is equal to as. So s is equal to b square minus u square by 2a. So here you substitute. What is v? V square minus v naught square by 2a, and the time is 1 second. Okay, so time is, t is mentioned in the question. After t seconds, I think question, is it typed correctly? I think if it is t seconds, no, it is t seconds, then the answer is v square minus v naught square by 2at. So the correct option would be option B. Option B is correct for question number 49. Next, 50. For a particle is in uniform circular motion, okay, related to one complete revolution. One complete revolution, what is the answer? This is a direct conceptual based question. Average speed of the particle is 0. Okay, option C will be correct. No. Incorrect. Yes, incorrect one is option C is correct. Yes. Next, a body of mass 10 kg is kept on horizontal surface. The coefficient of kinetic friction between the surface is 0.5. Mu value given, mu k value is given, mass value given, horizontal force of 60 Newton. So this is the force, capital F, external force is applied. Resultant acceleration we need to find out. So for this, if you just draw a diagram also, you can understand that. So here, if we can draw a diagram, this is the diagram. Capital F is acting in this direction, so acceleration will be here, and this is the small f direction. So how can I write the equation is capital F minus small f is equal to ma, and in place of small f we always write mu into normal reaction. Here in place of normal reaction we can write mu into mg. So the equation comes out to be capital F minus mu mg equals to ma. So A is equal to capital F minus mu mg by m. So that is how we will find out the acceleration, and the correct answer is D. You can calculate and check, the correct answer will be D. Now moving on to question number 52. A ball of mass 0.2 kg, okay, mass is given, thrown vertically down from a height of, here you can see that it is thrown, not dropped. When it is dropped, initial velocity 0, but when it is thrown, it has initial velocity. The height h is given. It collides with floor and loses 50% of its energy and rises back to the same height. The value of its initial velocity we need to find out. So here, actually direct apart from the derivation part, if you skip the derivation part, you can remember one formula, V is equal to root 2GH. Do you remember this formula, V equals to root 2GH? So direct substitution and you will get the answer. So option will be correct, option will be A. But otherwise also you can take the energy conservation part. The total energy before collision is equal to total energy after collision. You can do it and solve for it, then you will get the answer. But yes, after the derivation only, final answer you will get this. Okay, anyway, the complete solution is provided to you in the description, so you can check from there also the total derivation. Next, question number 53, the moment of inertia of a rigid body about an axis. Complete theory bit. So moment of inertia of a rigid body about an axis does not depend on shape or size. It depends on the position of axis of rotation. Yes, option C will be the correct answer. Next, 54. 7 identical discs are arranged. Mass M, radius R. Let us see the diagram so that you will understand better. So discs are given whenever and this is the axis of rotation. So for this disc, it is passing through the center. For this, now here what we need to do is we have to use the perpendicular axis theorem and parallel axis theorem, that application, and this is a complicated question. Yes, this is a complicated question. Here the formula is I equals to mr square by 2 plus, how many are there? 1, 2, 3, 4, 5, 6 are there. So 6 into, for them parallel axis theorem. See, from here one axis, from here one axis, this is the perpendicular distance. For the discs around the center disc, I need to use the parallel axis theorem. So by applying parallel axis theorem, mr square by 2 plus m into 2r. What is the distance? R plus r, 2r. 2r whole square. Now solve this, you will get the answer as 55 mr square by 2. So the correct option will be option C. Next, question number 55. The true length of a wire is, okay, original length given when the length of the wire is measured using an instrument A. The length of the wire is 3.5 centimeters when the length of the wire is measured by using instrument B. It is found to have length 3.38 centimeters then. So, okay, so true length is given. Let us see the options, then you will see. So here what is given is x is equal to 3.678 centimeters. This is the true value given. And XA, let us name this as XA and let us name this as XB. Okay, this is XB and this is XA value. Now you can see that XA is and XB compared to this XA value is more accurate because 3.678, 3.5, 3.3. First digits you see, this is more accurate and this is more precise because 2 decimals, up to 2 decimals it is given. So it is more precise. Okay, so this analysis if you can make, from this the correct option will be option A. Okay, so this is kind of theory bit. Now moving on to 56 question. Stretched wire of material, Young's modulus value given here, Poisson's ratio given, lateral strain is given, elastic energy density we need to find out. First of all, if you remember the value of formula of Poisson's ratio, it is the lateral strain by longitudinal strain. Do you remember? Lateral strain by longitudinal strain. Longitudinal strain. So longitude, the other formula is delta D by D by delta L by L. So if you find out delta L by L, if you can find out delta L by L, then we need to find out energy density. So the formula is U is equal to half into stress into strain. By using this formula, we can find out the stress. Okay, so stress, if you can find stress, no need. Energy density, so directly you can substitute here because strain is nothing but delta L by L. Strain is nothing but delta L by L. So the correct answer would be, you will be getting, when you calculate, the correct answer will be option D, 16 into 10 power 5. Okay, next. A closed water tank has cross-sectional area A. It has a small hole at a depth H. Okay. R is much less than. Okay. So let us see the diagram here. This is the diagram we have. The height above the hole is small h. Height below the hole is capital H. The diameter of the hole is given as 2r and the pressure here is P naught. So this is actually, you can apply the Bernoulli's principle and solve it, but after solving, this is a direct formula. So I would say rather you can remember this formula, pi r square. This is a Bernoulli principle application. So Bernoulli principle application derivation part anyway you will be learning in the class. So by the time you prepare for all these things, you just have to memorize this kind of formula so that it will be helpful for you. So that is a direct formula I can say. Next, 100 grams of ice at 0 degrees Celsius mixed with 100 grams. This is a calorimetry. Okay, in calorimetry what do we do? The Q lost by hot body. The heat lost by hot body is equal to the heat gained by cold body, right? By cold body. So just identify which is the cold body and which is the hot body. So ice at 0 degrees Celsius is the cold body. 100 grams of water at 100 degrees Celsius is the hot body. But here we need to use a small logic that when ice at 0 degrees Celsius is mixed with water at 100 degrees Celsius, definitely ice will melt. So for cold body we have to write mass of ice into L of ice plus mass of ice into specific heat of ice into delta theta. Similarly for water it is not changing its state. So mass of water, specific heat of water and a delta theta of water. Okay, so delta theta, how do you write? Delta theta of water, it is at hot body, so 100 minus theta mix, and for delta theta of ice it is 0 theta minus 0. Okay, so theta we need to find out. Theta is nothing but the theta mix. So when you solve, the correct option would be option A. Next, question number 59. PV diagram of Carnot's engine is shown in the graph. The engine uses 1 mole of ideal gas. Okay, 1 mole is given and heat supplied to the gas is given. Okay, Q, delta Q or Q value is 8000 joules. Heat supplied, so it will be positive. Okay, delta Q. So if you just look at the diagram, so this is the diagram. We have to use the formula eta is equal to 1 minus T2 by T1 is equal to W by Q1. Q1 is nothing but heat given to the system. Okay, so substitute in place of here we can write, because the direct value is not given, nRT we can use. So by substituting these values, and we have to use another one also, PV is equal to nRT. We need to consider PV is equal to nRT because A to B, it is a PV diagram. So A to B, it is a isothermal expansion. Okay, so B to C adiabatic expansion. So by applying all those conditions, you will get the final answer work done as 3000 joules. So option C will be correct. So the detailed explanation anyway it will be given. You just have to identify that this is a Carnot cycle. This is a simple Carnot cycle. So by applying Carnot cycle only we will solve the problem. Next, question number 60. When a planet revolves around sun in general for the planet. So just options, if you go on checking, the angular momentum about the sun and aerial velocity of the planet are constant. This is second law of Kepler. Kepler's laws, if you have any idea. So Kepler's law, second law application. So that is how we come to an end of all the 60 questions successfully. So yes, there are certain questions which are direct, which can be directly answered, which are conceptual based. But yes, there are questions which are a bit tough. So what I give you another information is, for this session whatever solutions are given, the detailed solutions are given in the link given below the video, that is in the description. So you can see the description for the link and find the detailed solution and key. Thank you all.